Okay, this is Chapter 7, Exploring Problem Solving with Software, Apps, and Games. A little continuation on from what we did in Chapter 6. Learning outcomes or discuss how technology generates problem solving and inquiry learning among students. Identify standard and open source software applications on most school computers. Evaluate educational software and apps. Compare and contrast different types of problem solving and inquiry learning software. Analyze educational games and simulations as learning resources, and give examples of digital games for learning, including virtual world simulation games and intelligent tutoring systems. The focus questions are: how do teachers use technology to promote problem solving and inquiry learning among students? What are the standard and open source software applications on most computers? How can teachers evaluate and use different types of educational softwares and apps that are available today? What are the key debates, and there are many, about using computer games and simulations as learning resources? And what are digital games for learning, and how can students and teachers use them successfully? Well, we have different ways of solving problems, and one of them is through inquiry learning. And there's methods researchers use to solve problems in academic fields, and we research, we look, we investigate different ways to solve problems just in your academic content. Educational activities where students ask questions, make predictions, test theories, and revise ideas. So that's somewhat akin to the scientific method, where you make a hypothesis and yada yada yada. So we we have students do some what's called discovery or inquiry learning, and that's where we have them investigate. And we try to find opportunities to engage students in learning across real world situations and issues. And the key here is the real world. Um, for example, in my content area of technology education, I'll do a thing called biosand water filters, and we'll make them out of 2 liter bottles, and they simulate a biosand water filter that can be used anywhere in the world. And it's just really sand and gravel, but it cleans 98% of the water, makes it drinkable. You can put cruddy water in it, and it makes it drinkable. And that is a real world context, because the number one killer in the world is not AIDS, not uh, heart disease, not cancer. It's bad water. So I can relate what we're doing to real world situations. Now that's my field. You can do it with any content area. You have to find real world situations that you can relate to the students. Um, the steps in problem solving, Pollyanna identified, or Polya identified essential steps for solving problems, and that's simply understanding the problem. What's the context of the problem? Why is there a problem? Is there a need for something? What's going to happen when the problem is solved? Okay, different strategies, solving strategies that can be investigate, do field work, all these other types of things, and then check and evaluate and reflect on the results. What happened? Can it be done better? Can we retool it and make it work better? All these questions have to be asked. However, real world problems are often complicated and messy, and that's very true. Um, they're also ill structured. So um, sometimes it's not as easy as we might think. So technology can help us with that through um, looking at different websites and so forth, and doing our investigation, and see what we have and see what we can do. And oftentimes there may not be a real solution, but we can often figure out something to get our point across, and something that students can identify with. and investigate and come up with their own problems, and you'll be surprised. Computers and software. I'm not going to go through this. We have hardware, software, system software, operating systems. That's Mac, OS 10, Windows 7, 8, 9, 10, whatever is going on there. Um, we have, so you guys probably, hopefully, know this stuff. We have standard software applications, of course, word processing, databases, spreadsheets, browsers, communications, presentation, antivirus, and specialized software. And specialized software is anything from Photoshop to Movie Maker to any type of thing that's really not a standard on the computer that you may want to use, although Movie Maker is, but there are different ones out there. And with the advent of apps, um, man, it's almost like it's a never-ending app parade out there of specialized software. So we have this stuff called open source software, and that simply means it's free. Um, Commercial software that you pay for when you buy a computer is Internet Explorer and Safari, although you can download them for free. So I'm not really sure why they're considered commercial software. But an open source software alternative is Foxfire, and sometimes open source works better than commercial because Foxfire works a lot better, in my opinion, than Internet Explorer or Safari. That may not be true with all software. Word is much superior than the free OpenOffice Writer, but OpenOffice Writer and other things like that work and can get you through in a pinch. Things, special software for like image editing would be Photoshop. And there are a ton of image editors out there now on the web, and certainly tons of apps out there for image editing. However, in this case, Photoshop is far superior than anything I've seen out there, and I've seen a lot of image editing software. But the free ones can get you through and do things you want to do. I look at Photoshop more as a industry standard used in desktop publishing and journalism and those types of things. Selecting an evaluation of software and apps, you need to ask these questions, and we can identify good software by being able to recognize poor software. And the key three elements here is the computer, not the child, controls the activity. Is the computer doing most of the work? Is the computer doing more of the manipulation than the child is? If that's true, it's probably not a good software. Does a game program promote competition? Well, competition can be good, so that's a 50-50 there for me. But stereotyping or violence are out. We do not want them in our classrooms. We don't want anything like that. But a little competition never hurt anybody, particularly if you're, a lot of software you're competing against the computer, and that's not really the computer controlling it, things. You're controlling it. You're just trying to beat it. And tutorial software and things like that, that's not too bad of a thing. The software favors quick reactions over long-term thinking. That's something that's we need to look at when we look at the software. We want students to be able to think and use their cognitive skills to look at what the content is we're trying to present to them. And we want to try to promote long-term thinking over quick reactions. That's not always going to be the case. You can find good software where they do a lot of quick reactions. They can be relatively good, but overall, we want to try to find long-term thinking applications within the software. Papert, who is one of the major players in constructivism, that philosophy we talked about a couple chapters ago, he talked about, will a child program the computer, or will the computer program the child. So, excuse that window. Um, Again, that's what I was saying earlier. We want the child to manipulate the software or the app more than the app manipulating the child. So, think about that. Criteria for evaluating software and apps. Again, we have 5 criteria here that you would ask about. Does a software feature include resources? Are there books? Are there websites? Are there PDFs? Is there something for the teachers to look at to try to help them manipulate and work the software uh, in the best way possible for their students? Is it current, thorough, age appropriate, clear, and fully referenced content? You may not get all those things to the extent you want them to be, but if there are elements there of the second one, that's a good thing. Is there some type of assessment tool that you can actually record and has guidelines, pre-test, post-test, quizzes, those types of things, scores, if they're playing a game? Um, is it easy to use? Okay, can you install it easy? Does it have smooth multimedia graphics, or is it clunky? Those types of things. Some softwares look really, really great on the box, and then they're a bear to work. And to get from point A to point B, you have to jump through 50 hoops. That's not good. And does it promote creativity, higher order thinking, collaboration, problem solving, discovery, learning, all those types of things that we've been talking about? So that's how those are the things you want to think about when you evaluate software. And as teachers, educators, workforce people, whatever, you may find a software that you really think will help the students, and most schools will allow you to buy it if they have the money. But you want to evaluate it before you do it. You want to do a good evaluation before you spend someone else's money on it, because if it's bad, that's bad for you. It makes you look bad. So you want to think about these things. Um, Higher order thinking and lower order thinking. Does software encourage higher order or lower thinking? So Bloom's that we talked about in the lecture, taxonomy of higher order thinking, um, we like to do creative evaluating, analyzing, applying. And then the lower order thinking, if we don't do these things, that would be lower order thinking type things. So understanding and remembering are great. We want them to understand and remember, but we try to do that through creating and evaluating, analyzing, and applying. So, does the software do that stuff? That's what we want to know. Promote higher order thinking. Software and games that promote higher order thinking should include complex storyline with open-ended activities, and we have open-ended and closed-ended activities, and we can think of that in a way of open-ended and closed-ended questions. An open-ended question, or let's go backwards, a closed-ended question is a yes or no answer. Open-ended, we get some discussion. So it's the same with the activities. Are the activities shut down really quick with just a click, or is there some type of something the students have to do? That would be open-ended. Characters who become learning companions. A lot of apps and software out there, you'll find that, particularly in the younger ages, there's a monkey or a clown or a, fairy or whatever who help the students through the software. Real world settings with complex puzzles. Well, we talked about real world setting. And is what they're doing complex enough? And it doesn't necessarily have to be puzzles, but is it something that they can use to promote complex thinking? Opportunities for game players to interact with virtual characters as they play the game. Again, that would be akin to the characters become learning companions. So, opportunities to replay the game with different outcomes. That's important. Is the same thing going to happen over and over and over again? And again, are the graphics interesting and engaging? Online software selection resources for teacher. There are Edemic Dictionary, and that's a you can look that up on the web, and you can find reviews of software and ratings that people use. They have the Entertainment Software Rating Board, which also gives age appropriateness for all types of software, not just educational. Value Tech, again, reviews, links, um, and it also includes lesson plans, policy information, and teacher development. And then there's this one called StopBadWare.org, and that's kind of a watchdog uh, type situation where if you see something out there that you don't like or you think's inappropriate, you can go to the site and report them. Um, so there's that. Composing and calculating. We have digital writing or digital composing, and that's writing with computers and writing for expressing ideas through websites, emails, blogs, and wikis. That's pretty straightforward. We generally use Microsoft Word, copy and paste into a wiki, or leave a link. And in case of our class, we're leaving links to Microsoft Word documents, but any bloggers out there know it's generally better to write something on Microsoft Word, get all the manipulation you need to be done, all the corrections you need to be done in a Word, and then copy and paste it on a website. Technology and math learning. We use graphics, spreadsheets, calculators, geometry visualization. Microsoft Excel can do a lot of that. So those are the composing and calculating softwares. Probably know all that stuff, most of that stuff anyway. Um, there's a lot of different building, inventing, creating things. Kids Picks, you can look that up online. It's a good multimedia online. Art Design Studio, Google Earth, I showed you in an earlier lecture. And then we have this thing called Object Oriented Programming. And there's some stuff you can look up called Squeaky Toys and Scratch. Um, and that's where the user creates objects that react to user programmed instructions. And without me being able to show you what that is, because I unfortunately don't have internet right now, I'm going to ask you to look up Squeaky Toys and Scratch so you can see what this is talking about. Which generally, you know, you create some type of object and like a ball, you make it bounce against things. That's very elementary definition of this open-oriented programming, but that's basically what it is. You can do all types of things with it. So get a chance, look up the Squeaky Toys and Scratch. They're fun to look at. Visual thinking and concept mapping. I'm not a real big fan of concept mapping, but again, it's I'm going to try to provide a link to that because it's a lot of people in education thinks that's a big deal, and just because I don't like it doesn't mean don't want you exposed to it. So I'm going to put a link to what concept mapping is for this week, so you can see what it is. And then visual brainstorming. We know what brainstorming is, and there's different software that can help out there. Kidspiration is a good one. Inspiration, Inspire Data, Persuasion Map. Again, you should look these up and just take a quick look at them for help with brainstorming activities. Computer games and learning resources. Games have a wide reach, so we want a multiple delivery system that allows access to almost the entire population. We want it to be standardized somewhat. Have a strong connection between games and popular consumer culture. That's important because that's kind of a real world context. If we can relate it to something that kids are that's going on in culture today, the kids can relate to it better. So we want to do that. And always a learning storyline and characters. We've gone over that. An extended impact via gamification. Adding game elements to non-game element situations adds motivation to students. So for students rather. So we want to not always use the game, the software elements. We can add a game of it to our own. For example, kids who score higher in this game um, get some type of reward, and that's up to you. So we try to do something else besides the actual software. But when we do that, sometimes winning takes priority over learning. So they're more interested in getting the reward than they are learning. So we have to be careful there. Um, Debates about game and gaming. Well, as I said at the beginning, there are people who don't like this stuff. So the negative views is it can increase aggressive and confrontational behavior. It can decrease empathy and concern for other people. And these are really the games like Grand Theft Auto and so forth and so on. When my son was growing up, he was glued to Grand Theft Auto, and he had no problem killing people in the game, and same with Call of Duty and those types of things. Um, and the fear is it desensitizes people, and they just don't care about death and those types of things, and they think it's funny, So that's one of the negative views. It can encourage less active lifestyles. Yeah, kids sitting there playing game all the time and not getting out and doing things. It can promote obesity and stuff like that. So, um, and again, this emphasizes to get the right answer to obtain a reward approach to learning, but they also have that approach to life. They can't understand if they get the question right why they don't get a big prize or they don't get some type of positive reinforcement. In the real world, you're expected to have the right answer, and in college and school, you get a grade. In life, you may not get anything. So you have to be aware of that. And it limits open opportunity for open-ended and exploratory play with things like wooden blocks, paint, and countless other material. In other words, you're playing with the computer rather than doing hands-on things. So those are some negative views. The positive views are it promotes strategic and analytical thinking, and that's very true. My son also loves the football, Madden, and he's so good at it. We'll watch a real football game, and he'll say, "Dad, you should do a bubble screen 2 5 7 2 blah 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 blah." And 9 out of 10 times he's right. It amazes me. So it does promote real analytical thinking and problem solving and planning skills. Um, it encourages students to engage in repeated practice as a way to achieve mastery. That's pretty self explanatory. Also, a good positive view. It can be a stress reliever, although, virtually killing people, probably not the best stress reliever. Probably find something else. But there are nonviolent games that can deal with stress in adolescence. It promotes visual learning and visual literacy. That's true. And promotes in the role learning, which again is this virtual world we're going to talk about. And that can be a good thing. Don't worry about this graphic. Digital games for learning increase motivation and engagement. Um, Games offer students 5 essential freedoms. And this is important, the freedom to fail. Can't, if you don't make mistakes, you're not going to learn. So there is that. And it's very hard to master games right off the bat. Although my son would probably tell you different. But freedom to experiment, freedom to fashion identities, freedom of effort, and freedom of interpretation. Those are all pretty straightforward. I think you can understand what they're talking about here. Simulation games, again, they offer uh, really good academic information and skills that the students can use. Um, there's different levels they go to, and they master one level, go to the next level, master that. So simulation games are very good. Virtual worlds, again, the Second Life I was talking about, you ought to check that out. And virtual worlds for children are becoming a lot more popular. They can integrate play and puzzles. There's Pop Tropica you might want to look at, Panawapa, Zula Patrol, all these other types of things. You ought to just grab one of them, take a look at it. It's not required, but if you really want to learn about this stuff, you'll take the time to do it. Okay, I'm not going to require you to do it, but you should look at some of these things. Strategies for using games with your students. Minimize the use of games that teach isolated skills. We want to try for something that teaches a myriad of skills, a lot of different skills, not just one. Don't use games that just are win and lose. Try to find happy medium ground between the win and losing. Discuss with your students the games and the content before you let them go. And try to play the games with them. The students like that. And finally, inquiry learning using intelligent tutoring systems. Um, there are a lot of tutoring systems out there. They tend to be for remedial things, such as math and science, history concepts, things like that. But there's also tutoring systems out there for just about any subject matter you could think of. What I was talking about, the Khan Academy a couple lectures ago, would be a great tutoring system for your level. But Khan Academy is also great for high school students. And I'm sure down the road there's going to be a Khan Academy for elementary if there's not one already. Um, and that would be a good example of an intelligent tutoring system. Um, but there are software out there that you can buy um, that will provide instant reporting to you if what's going on with students. You can't really do that with the Khan Academy, but there are software out there that can do it. And it says especially effective in math learning. Well, yeah, but there's also science concepts out there too. There's a lot of stuff coming down the pike, and these intelligent tutoring systems um, are very good, and they're just going to get better and better. Okay, that's the end of this lecture. We'll see you next time.